Okay, welcome back, everyone. I hope you all had a enjoyable lunch and got a chance to visit the vendors and maybe take a spin around the museum. I heard the otters were being very active, along with our funny ducks. This afternoon, we have a couple of great workshops lined up for you. The first one is Code-Based Resilience with Josh Stack. Josh is the founder and principal at Stack Resilience, and he's going to talk more about using a builder's framework for the 2025 New York State Energy and Uniform Code to achieve above code resilience measures for key disturbances, including things like extreme heat, flooding, severe storms, power outages, and other disturbances that we're seeing more and more of here in the North Country and across the state. And he also brought some special guests, some next generation. I just want to just acknowledge you all here down front. I'm so happy to see you all. We need young people coming into the workforce and following these energy green energy pathways. Okay, I'm going to turn it over to you, Josh. Thanks so much for being here, and the floor is yours.
Great. So thanks, everybody. I'm sure if you're like me, you find out at lunch how much trouble you're actually getting into not being on the site or in the office. So what I'd like to do with this is kind of talk about the code-based resilience framework that we use for our projects. Kevin's here, so I'd really like it to build on the morning session and make it useful and practical to what everybody here does. I'd rather not just talk about what I think is important. I'd rather hear from everybody about what you think is important, any questions, thoughts, feedback. I really try to learn more when I come to do these presentations than I give. So jump in, raise your hand, shout it out either way. Any questions from the morning, Kevin and I can answer. We're happy to do it. So yeah, I've brought some of my kids here today just to see what they can see what I'm doing when I'm not home during the day. So I would say, make the same joke my father makes, that he said he's worked for me for 40 years. But I would say growing up on a construction site, I kind of remember that a little bit differently, where like child labor laws didn't really apply. Maybe OSHA standards weren't quite what you think they might be. But anyway, I'll jump in. So this is one of the projects Kevin showed earlier about where and how you start with code, but we try to start even before that with site and try to understand where we're building, even if only from like a risk management strategy about what sort of hidden conditions in the ground, prevailing winds, humidity from the lake, whether you're east or west side, how you do your vapor wetting and drying strategies, your air control layer, your primary moisture control layer. We do it differently depending on where we are and where we're building. Like Kevin said, if there's 8 different climate zones, I'd probably say there's closer to 80, or however many different ecosystem types you have where you build. And the microclimate at the bottom of your foundation is going to be different at the microclimate at your soffit and your fascia, or at the side wall of a complex roof system that I'm dealing with now on the other one we're building. So how we use the materials really matters. And one thing I realized, I started out in ecology undergrad and then thought for a while I didn't want to come back to the family business construction, so I ended up in law school. And I kind of joke about being a recovering attorney. I don't practice anymore, but I still take that framework of research and say, why am I doing what I'm doing? Building science is a good framework. Huge debt of gratitude to everyone, Joe Stiebrick, John Straub, Terry Brennan, kind of all the early leaders of saying, hey, there's a science to buildings. So what I would say is there's a science to resilience that can be applied to buildings similar to building science, that builds past just the laws of physics. So one thing we've tried really hard to do in the past 25 years, I've been back with Kevin at the family business, is not do what I say I think is right, but to go out and learn and start with code. And then when you move from code, starting to see what else is out there. So this is actually a mitigation saves federal study about the resilience benefits of construction, of just simply adopting the most current code, iCode. About 11 to 1 just to adopt the current code. So as much of the struggle that Kevin's talking about this morning, the learning curve we're all going to have, the pain that we're going to experience on site, because I can definitely tell you that my duct systems will not pass as they sit now under the new metric if they're tested. I only know that because when I test my ducts, they fail. And then I understand where and how I have to make the corrective work before drywall to fix them. But so It's just to say, these studies are out there. They show the cost-benefit return of resilience strategies of both current code, but also above code measures. So it's there. So I can go to a client and say, I understand here's our code minimum, here's our baseline, but I have these other set of recommendations I'd like for you to consider for your project. And it might feel like health to you, it might look like comfort, it may be a lower utility bill, or it may be a higher utility bill. So for us in the custom residential market, trying to understand what our client values and making the argument to them, but then also the code officers about why we're doing things a little bit differently. So this is a study that's out there, I can share it, but basically it sets a baseline that if you do it cost effectively, you can create a lot of value into the future. So it's similar, Kevin had a similar one. I'll show you a project a little bit later because we not only build, but we also do a lot of forensic consulting or get a lot of calls typically from other builders like, hey, there's smoke coming from my ceiling, can you come figure out what's up? And the firefighters are saying it's not a fire, so what is it? So what we try to do is look to see what tools are out there. But for this slide, what I really wanted to just communicate is if the building and energy code look at efficiency as the baseline, how can you use efficiency to start to build resilience? And so a lot of really good studies out there in terms of, I think everyone here has probably heard of passive survivability, how long you can shelter in place in your home if the power goes out. Typical buildings less than a day. Code is about 1.2 days, 1.5 days here in climate zone 6. If you start to look at passive building like FIAS, you can extend that to 7 days. But then you also have to ask if dealing with extreme cold, the same strategies apply to extreme heat. And they generally don't. So the expectations of clients when I go say, hey, if I go to a passive level for your house, here's the cost delta, but here are the benefits for it. I should probably be very confident that I'm right in what I'm recommending so that I don't get a call, like Kevin had said, a builder 8, 10 months later, 12 months later, hey, you told me if I built a FIAS or passive house or invested in more insulation and a primary air control layer, I could just sit and shelter in place for 7 days. Well, the power's been out for 5 days and it's not livable. I can't be here anymore. So what we try to do is take that scientific basis first. We rely on studies like this one. Pacific Northwest Natural Lab has done this, looked at efficiency as a baseline. I won't kill you with the graphs, but it basically shows you if you build a code or FIAS or above code measures, how much better that house is going to perform in terms of passive survivability, but also reduce mortality, windstorms, flooding. Clear benefit there too. Really won't go into it. I'm sure the slides will be available and I can share these studies. So for the code officers, ICC, International Code Council, has also looked at resilience. There's a resiliency initiative that they've developed. A lot of the findings come down to, well, what is resilience? And, it's probably one of the things that we try to do is say it's not what we think resilience might be, a lot like what people talked about green building 20, 30 years ago. Well, I think green building's this and that, and LEED came out, started to provide a basis for it. But so ICC looked at it, basically defining it, of what, to what, for whom. So it could be a multifamily building to flooding in climate zone 6 for disadvantaged communities that are particularly vulnerable to mold or particularly vulnerable to heat stress, whatever it is. So that lower chart in your lower right, that's basically current code provisions that relate to resilience. So as we start to look in how to add resilience to our projects, we start with the current code and say what code provisions are already there that we already have to comply with, and then what means and methods are we utilizing to do that? How can we do it a little bit differently so that our performance is higher? So it's not different than the code, it's code is baseline plus. So lots of studies here. Some of the findings they've come to is like for the energy modeling that Kevin talked about and that everybody here is familiar with, based on historical conditions, not what the anticipated future temperatures are going to be. So if we're constructing houses that we'd like to persist, function for 100 years or more, or however long you might want to imagine that your building is going to persist, what future conditions is that house going to encounter, and is that house designed to those future conditions, or was that house designed based on historic conditions? And I think everyone knows that that house is designed to historic conditions, historic temperatures, historic water, rainfall, snowfall, and the future conditions our buildings are going to encounter are significantly different than even what the recent past has shown. So from a duty of care, if we're building these houses for clients who want to be in that house with their grandchildren, 30, 40, 50, 100 years from now, I feel we have to understand what that future weather, that future climate, that future rainfall, precipitation, whatever it is going to be. And then that directly relates to our 4 primary control layers, where we place our air control layer in the wall, vapor control layer, whether it's Seabrick's perfect wall or if it's a vapor open assembly in the passive house world. We think pretty carefully about that to understand those heightened maximums that building is going to encounter. Everything from heat on roofing, heat on sealants, the variability that Kevin mentioned in the morning session. When you go through, a 70-degree swing in a day, repeatedly, you're building all the sealants, the adhesives, all of the connections, the intersections, the different components of the assemblies are going to feel enhanced stress and pressure. And so how are those assemblies going to perform into the future? So it's one thing to hand the key over, like Kevin said, and okay, we've built it to code, we've built it, we've performance tested it, but how is it going to function? Because that's really what our clients are paying us to do, not just deliver a code-built house. So I agree completely with you, and I think I'd be interested to hear everybody else's day-to-day experience, because it shifts from minimum, anything less is illegal, on, to, all right, how are we going to achieve code here? And then it's almost like the focus for the project just becomes, okay, you got your project drawings, maybe builders are looking at the reference standards, maybe probably not. Maybe they're looking at the manufacturer's installations instructions, probably not. I mean, this is something I'm interested in. How many code officers, when you go to a construction site, the manufacturer's installation instructions are there for you to review? I'll say I do my best to have it all on the site. We've got a baker scaffold that sits in the corners, my desk, stack of paper that big, but then I come after lunch and the pizza and the chicken wings, and it's like a bomb went off there.
I'm practical about it, right?
Yeah, and contractors often rely on their subcontractors, and that's where things like electrification pose real challenges, because when subcontractors, at least in my world, the custom residential world, there's decade-long relationships with carpenters that are on my jobs. I was this tall chasing them with a broom when they worked for my father, and their sons and their daughters are now second, third generation there. But if they only do boilers and gas, it's a shift to a cultural change. It's not just an equipment change, not just a knowledge change. It's much deeper than that. No, I think code officers have the most difficult job in the industry, because you're expected to have such a depth of knowledge. Like when you come to a site, I'll show you one of the forensic projects where there's manufactured stone. I won't say fake stone. It's called best behavior here. Manufactured stone meaning EFIS. And so you've got 2 different installation instructions which don't align. It transitions. Full horizontal transitions, flashing details are different. But as the code officer, your knowledge to look at those installation instructions, verify whether I, as the builder, actually installed it pursuant to the directions. And sometimes some of the manufacturers are better than others, right? They've got 60 pages of details that you can follow and align them. But when we use innovative products, some of the wood insulation, for example, that we used, was one picture on a website that said, here's the installation. I had to argue with the wall provider for that project, because they said it still just violates fundamental good practice. It's not thermal control, it's not continuous air control. And they're like, well, show me where I'm wrong on the installation instruction. It's like a cartoon picture, and I'm like, well, I can't, but you still have to do better than that. So hazard plan, New York's done it, ton of information on that, different hazards, snow, flooding. So that's the thing about being a builder, is there's more free information out there and free details out there now than there ever was. And they make it so easy for us. It's just literally pictures most of the time that you just follow it, and that's hard enough to do often in the field when you're trying to assemble these materials into assemblies that perform, trying to pick where your primary air control layer is going to go, your primary vapor control layer, how and where they're going to be. So that's just another website you can go take a look. So one of our projects, we just did a more stringent local energy code for Hastings on Hudson. And this is a really interesting one for local municipalities that want additional flexibility and control over their energy code. As long as it's consistent with the state energy code and more stringent than the state energy code, a local municipality can actually adopt a more stringent local energy code. So I'll show you an example from Hastings on Hudson where we wrote the code. It went to DOS for approval under this energy law 11-109, and they're actually enforcing it now. Town, City of Ithaca has done the same thing when they shifted to all electrification. You know, the secret of that, when the headline came out that Ithaca adopts all electric energy code, it really didn't. What they provided was optionality and no mandatory requirements, and just made it a lot easier to choose the all-electric option than the gas-fueled option. Similar to what Kevin talked about this morning in terms of 15 versus 20% efficiency, depending on whether you've got a gas appliance or not. So this is in the new energy code. It basically tells you exactly, gives you the permission to do it. 11-109 tells you how to do it. But the interesting thing here is the local jurisdiction, the code officer gains the ability to interpret the provisions of the more stringent local energy code. So typically, you'd have to go to DOS, submit a formal request, ask for an interpretation or variance. If you adopt a more stringent local energy code, then you can interpret and apply the code. So Hastings on Hudson, green code, this is one way that we use the energy code to bring resilience into it. This is one of the resilience provisions that we drafted for that code. Basically said, hey, if you go to a site, look at the top 3 things that are going to hurt your building or the people in it, and figure out how to deal with them. Whether it's flooding, figure out whether you're in a 100-year flood zone, a 500-year flood zone, whether you don't have to worry about it, figure out whether snow or wind or whatever it is a risk. And then where you go is back to all the state level resources. The hazard plan will give you information for that jurisdiction on what those risks are. I would say most builders, if they're paying attention, are going to figure out what those risks are on a site better because they're going to try to manage them anyway, whether it's flooding through on-site stormwater design, whatever it is. But you know, you can also put a lot more into just the energy code. These are some of the provisions just per site from the Hastings code. And this was the Hastings Village Board of Trustees saying, hey, these things are important to us. Put them into the code, assign points, let's pressure test it with a few actual projects to see how and if it works. So this is a way that towns, villages, if you're dealing with things that are issues, to bring into the energy code through this process. So it's one way to bring resilience to your jurisdiction. I share it because there's code officers here. Worked out pretty well. Now I want to get to more of the resilience science of it and why we make the decisions we do on what we build. So the first thing resilience would say, and I think everyone here would agree, is you can't just focus on one thing. You can't just focus on the insulation or the mechanical ventilation. And even the code itself makes these really tenuous connections between, you know, how to size manual J, D, and S, your HVAC system, how to calculate ventilation. But as Kevin said, that all lives in a model and on paper. It doesn't deal with the lake houses that we build that are 6 to 8 bedrooms with 2 people occupying it for a couple weeks out of the year. And setting those ventilation rates in a way that doesn't destroy a very expensive millwork package or in the summer load the interior with too much humidity and vapor to start growing mold. So it's a way to shift from that baseline, to your point, the minimum that you have to do to comply to get your CO and do what the client hired you to do. But part of it is looking back, certainly learning from what that site has done through time in the past, but then understanding, you know, things are changing. And no matter what someone's perspective is on climate change or extent or cause, whatever it is, I think we all can agree there's a higher, or at least seems to be a higher level of variability, rainfall, temperature, precipitation, all forms, that our buildings have to deal with. Extreme heat's one that we focused a lot on because we're doing the extreme heat plan for the NYSERDA codes team now. And it was really eye-opening looking at durability of just typical building components and materials. When you go to read the performance criteria for electrical wiring, the Romex, what's your maximum temperature of Romex in an unventilated, a ventilated attic? Are you getting close to the maximum temperature before you avoid the manufacturer's warranty and the performance of the Romex? I asked my electrician that, and he sent me a picture of yellowed out neutral wires on a panel that he had to change after 8 months, different builder, because the mechanical room was so hot that it started to impact the wiring. So all these unintended consequences, the new breakers, new GFIs, everything is giving off heat either from inside of the building or from the external environment, it's starting to have impacts on things that clients would never think twice until they see a problem. Then they look at you and say, why didn't you know about that? Or why didn't you encounter it? So for us, I won't go into this story because I'm probably a little behind time. All right. So one thing we do as builders, we look back 'cause we want to know what's in the ground. If there's an old foundation there, we got to talk to the client about structured fill, or if there used to be a river that flowed through or something that would give us a problem in construction. This was part of a Syracuse University project to basically help them, get to zero with residential housing. But so we went to I won't go into all that, but we went into the Adirondack Historical Society. And one of the sites we were building on, we saw the picture. And we're like, we don't recognize this building. What is it? It was demolished like most beautiful old buildings in our city centers have been in urban renewal in the 50s and 60s. So that's the Hotel Truax. It's 1920. It's a 4-story, 12.4 million pound hotel that they actually lifted off its hand-cut stone foundation, rolled it across the street, spun it 180 degrees, put it back down on its original foundation, and the hotel never closed. It kept guests checked in and out during the entire move. So we went to Syracuse University and said, we want to do deconstruction because deconstruction is a key resilience strategy. It's embodied carbon, it's workforce development, it's a value-added thing. And they were terrified of the idea of deconstructing a house, but it's kind of the reverse of construction. But when we showed them this and said, that's what builders did in 1920 Syracuse, why can't we just go do that on a site locally? And so for the Hastings Code, they put deconstruction in because you show them the data on deconstruction, the building science you can learn from it, all of that. But so that's just to say to look back into time is really important. So for us, time is part of the tool of design where we look to see historic conditions. We understand what the code is telling, the environment the code is telling us to build to with the climatic data that's included in the code. And then we ask, is that going to work here for the next 100 plus years? And generally not when you run into those limits with like the Romex maximum temperature, the maximum temperature of the caulks, what type of caulk to use. Because if it's a simple decision between silicone or urethane or whatever for a certain condition, and silicone's got this as a maximum temperature and urethane's here, then why not go with what you know is going to work and is going to be exposed to? It's just better building, less callbacks, less problems, however you want to phrase it. So we realized looking back is really important, but we also realized how the code treats a building at multiple scales. And so when I'm talking scales, structure, skin, so cladding, the 4 primary control layers that Building Science Corp talks about, how those are all integrated, because typically the code thinks about materials, not assemblies often, in terms of where's the primary air barrier. And one thing, one training I took that was really good was the FIA Certified Passive House Builder. I don't know if anybody else here has taken that course, but it's a really good exercise in looking at the different characteristics of each material in an assembly and understanding that there isn't just one line in that assembly, to Kevin's point, that is the primary air control material. It's an air control assembly. And then how are these assemblies going together at critical connections, top of, foundation wall to wall, from wall to ceiling, because that all really, really matters. Those are our vulnerable weak points in any assembly. So this is just a picture from a really great book Stuart Brand wrote, How Buildings Learn, meaning how to buildings experience change over time. So we just break it out, different components over time and what's going to fail and where. And we don't want to entangle a failure in a layer that should be there a lot longer. So structure should be there for 500 years. If you go to Europe, you see buildings that have been there for 1,000 years. So why can't we, to your point, code being a minimum, build a house for 500 years? everybody laughs at you when you say you're going to do it, and it's going to require maintenance, absolutely. It's not like you're going to leave the same roof for 500 years, but why can't it be there? And making sure each of those layers that the code deals with and how you install those layers is really critical, so that you're not having to demolish something in 30 years that could have been there for 100 years. So you get a lot of stuff like this, and I'll get into your point about innovation and creative materials. This was the argument I had with it was a prefabricated wall supplier that I was trying for a guest house. And I lay under the wall, I take the picture, and I'm like, okay, we got to talk. This isn't going to, it doesn't fly. They wanted to put a little bead of sealant on the corner there, and they showed me a cartoon picture online that said, look, you just use the sealant, and that we're only worried about air. I'm like, I'm not only just worried about air there, but, you know, when you don't have the manufacturer's installations instructions at a level of detail, how do you have that discussion with the subcontractor or a material supplier that, hey, you didn't do it right? And so it doesn't turn into just an argument that, you know, that doesn't have a clear baseline to it. Going on that, you know, I guess the only point I would make here, this goes back to the ICC resilience, is you always have to ask the question of resilience of what, to what, and for whom. So, you know, of an enclosure to hurricane for your clients, whatever it is, because that gives you specific metrics you can build to. You can look at the ASCE wind data for your location. You can look at fortified roofing standards, for example, that the insurance industry pioneered in terms of how to reduce your insurance premiums if you just build to the fortified level. And it's all really simple, good practice for roofing anyway. They give you checklists, very easy to do. And what you're trying to do, not just the specified resilience, but what the science calls basically adaptive capacity, general resilience. So to the unknown. So to like the microburst that the Adirondacks might see only once in 500 years. Do you design to it? Is it worth the investment from your client to do that, to not do that? You know, those are things to at least think about. And then to look into the near future over the next 30 years, which those state level resources do, to say, are those type of storms, severe storms, going to become more common in this area? And if so, maybe fortified makes sense for you, for the location. But this was one of our consulting projects we got called to your point. We'll get to the innovation. So we were building a house about a quarter of a mile down the road, and you know how like on job sites people talk, they're like, oh, there's this house down the road, it's got some trouble, but kind of bouncing back and forth. So one Saturday the owner called and said, hey, can you come take a look? We can't fix a roof leak. And so we went, Kevin and I jumped on the roof, said, well, we can fix the leak very easily, but how do you approach that? For me, frankly, I'm probably not a good enough building physicist to look at that like Seabrick would and Straub and pick it apart and use the PhD level analysis. But you've got manufacturing, installation instructions. Does anybody ever use or read ESRs at all? The evaluation service reports. So those are really critical. I'll show you a photo of one. They're for specific materials, and they are tied to the innovation section of the energy code, where the energy code says you're allowed to use innovative materials. I don't think I'd be in business very long if I just defined what an innovative material was and started putting them together on site. I would much rather have a validated, tested material for that and a tested system. And so what ESRs do, and we'll get to those in just a second, that gives you that baseline to do it, to take a little bit of risk, to put together a creative assembly or a high-performance assembly in a way that you can not only trust is going to work, but you're also protected if there's a failure somewhere because you followed that ESR. And, well, I'll get to the rest of the ERS in a second. But so as Kevin mentioned, installation is right in the code and installed in accordance with the manufacturer's instructions. So that is part of code. So any material that comes on the site needs to be installed pursuant to the manufacturer's installation instructions. And so for the followed all of our requirements, because there's always a gap, to your point. Always ambiguity, there's always a gray area. like here, manufactured stone has very detailed, and it's the Manufactured Stone Association, I forget the specific name, but they put out a very detailed 80-page installation detail booklet. And so print it out, study it, look at every transition on the house, and say, okay, you've covered maybe 80% of the conditions that I observe here. There's 20% you don't have in the book, so that's a risk to me unless I go ask somebody else who's thought about this for a very long time to come and provide some guidance on it. That's where, I think as a builder, the best thing you can have is some humility and just say, hey, there's things I know well and things I trust and I won't negotiate or break. But if there's an expert who's done nothing but manufactured stone for 50 years and has written that tech spec, and you can get that person to the site to look at that and say, yeah, I agree with you that my detail, my MSV detail in the Manufacturers Association conflicts with the EFIS detail. So do this, and then get a sign off and move forward. Yeah, because I mean, the power that you have as a AHJ code officer is really immense. I mean, part of the other training that we do for longer energy code is, I mean, you can require me to remove sheetrock to inspect the air barrier. If I don't get my air barrier inspection, you can make me take off. You know, a lot of builders don't understand that. I mean, it's one thing to come in as a consultant and say, you got to cut the ceiling over there to get to the ductwork to seal it for Energy Star or for FIAS or for LEED. But from an AHA perspective, you know, a client might say, you missed a LEED requirement. But a client's never going to say, how did you miss code? Why is the code officer making you take that off? So absolutely. So that's where, to your point, understanding how these different requirements play into the project and what weight they carry is really critical. Because if I just say, hey, I built to the energy code, but I didn't read the manufacturer's instructions, then I've not done my job properly. And if I don't go look at the ESR that is either fully consistent with those installation requirements, and then I can check that box and say, all right, code, manufacturer's requirements, which are code, ESR, all agree. But I don't necessarily trust manufacturers, to be perfectly honest, because to Kevin's point, with like hardwood flooring, it's a disclaimer. There's no way you're going to keep your relative humidity inside that house consistently between 40 and 60% without variability from those two levels within 1 year. I mean, I guess you really could, through intense effort, daily photo documentation, you know, all the stuff that you have to do, moisture content of the subfloor, kind of all these different things. But if you've done it before the turnover, then you can at least say, I've done my job with it, and whatever the owner does afterwards is on them. But I mean, often, particularly with modern materials like Seabrick and others, talk a lot about OSB versus plywood, and you know, the reduced wetting tolerance and the drying tolerance, and how we're making our walls tighter, and we're keeping our wetting potential up here, but our drying potential down here, which is causing a lot of the failures. So a lot of the modern materials just aren't what the old materials used to be. EFIS isn't stucco. And if you were to add humidification just for hardwood floors, you're probably destroying the building enclosure somewhere else. You know, with particularly an OSB, because there's going to be a failure somewhere, because as you get tighter, those failures are concentrated. So second law of thermodynamics is going to concentrate everything to that one failure point, and that's where you're going to see it. And you will see it because the modern materials are much less forgiving from a material chemistry perspective, durability perspective. What's that? Yeah, and so you know, if you put humidification in the house, the Mayo Clinic will tell you have to use distilled water because of the bacterial and other environmental contamination and just humidification, just what's in the water. They're saying you've got to use treated water for humidification, not just, you know, not just slap a humidifier on the return of your supply. So here, same thing, so reference code and standards, that's one of the other things that a lot of people, at least will run into, don't understand that the code books, there's a lot more to the code book than just the code book, and you have to be really aware that you have to go past that. But, so, you know, we come here, we look at it, there's one of the details from the Manufactured Stone Association, looking at the weep screed at the bottom of the wall detail, we're looking at the wetting pattern, and now we got to tell the client, you've paid a mason to go ahead, put the drainage plane on, which is just regular felt paper, the weep screed, all the rest of it. But with what we're seeing, we think that wall's wet. How do you know? Well, physics. We just believe it's going to be wet, and then you can get down there, put your head underneath, and see. I'll get back to it next. And so we told them we have to take it off because it's enclosure. Water's the primary damage function of building after fire and structure. So this will destroy. And this house was only 8 months old when we got to it in construction. So looked at it, started to take it apart. This was actually under the EFS elsewhere. That's the stucco wrap that we saw behind the wall. It was like a nice interior drainage plane that went down. That's a moisture meter at the bottom showing the OSB is saturated. Kind of flaked off in our hands when we even just tried to touch it. So there's the manufacturer's detail. We're looking at it saying, okay, well, that weep screed at the bottom is plastic. It certainly doesn't extend past the wall the inch that it needs to be. So you're already not in compliance with code. That's at least one code violation we're looking at there. And then the argument's really easy. It's got to come off. It violates code. It needs to be removed. Not Josh Stack thinks it needs to be removed because it's not a good installation or I don't think it's good quality. Violates code. It's got to go. And, well, I don't see it in the code. Well, look at the manufacturer's installation requirement. It's right there. That's part of code. Yep. Yeah, the one thing I learned on this one that I didn't, because I hadn't done EFS in a while, is it's not just the 30-pound or number 30 felt. You need a specific ASTM rating on that felt for it to qualify as a sacrificial WRB for that EFS system. So you can't go to Home Depot or Lowe's or local lumberyard and just grab number 30 felt, put it on the wall over your primary WRB because it doesn't have that ASTM rating. And then, in the forensics world, well, is it causing damage? No, okay, then I'm not. Some consultants would say that I'm not interested. I don't care. I only want to see things that have failed. So what if it has a rating or not? But here, not only did it not have the rating, but it also failed. So once you get into this situation, it's almost like the code just piles these violations on top of each other. And I say that as a builder because it's sometimes very difficult. If your EFS contractor shows up 2 weeks early or shows up with a truck full of felt, you're like, I don't see the ASTM rating on the felt. You can't use it. And then I'll call, an hour later, well, that's 2 weeks out, and I have to shift schedule. Well, you should have known that was the case. I mean, it didn't happen here, but hypothetically, you guys know, being in the construction world, that's how it goes. You pull it off the shelf and use it so you can keep moving and finish. So that's what we saw, stuff like that. So this is the ESR that in black, you can't read it, but it basically, in the event of conflict between the report and the report holder's published installation instructions, this report governs. So as a builder, that tells me I have to go read the ESR. And when you get to an enclosure, I think I read probably 12 ESRs of that, because it's not only the ESR for the stucco wrap, it's the ESR for the flashing, for any sort of caulking or sealant. Any piece or part that goes into that part of the assembly is going to most likely have an ESR tied to it. And so you have to go look at it, I think. And that's just down in the lower right. There's a website you can go. They're free. Sometimes difficult to discern because they're really dense when you read them. But you have to read them because if there's a conflict and you don't follow that ESR, you're at risk for it. So these sort of things, this was just after we removed the EFS. I mean, just poor practice, doesn't even comply with code. But how can you say it doesn't? Well, that's, again, the manufactured stone detail, I believe there differs a little bit from the EFS manufacturer's detail. But you put them together, look at it on the wall and say you've got multiple code violations there. It just needs to be redone. And this project's actually in litigation now, so the other part of it, try really hard not to go there because we typically represent the builders, not the homeowners. But this was the first project I've agreed to take over for a homeowner in a very long time. And I did it because the homeowners are just really great people, really close to home, and they just really needed help. So did it, but now the attorneys are fighting it out, and I'm getting questions that I never wanted to answer, like, hey, what did it, what's the damage here? So who knows what happens there. But so that's the bottom wall. When you look at it, everyone knows now, I think, to tape the bottom edge of the OSB to the ground is a good practice. But here they put the weave screed at bottom that doesn't, actually, you can't even call it a weave screed because it's not that per code. You see the stucco wrap tucked behind it. So, the steep brick thing, you've got your raincoat tucked into your pants here, and it does that. And so we're taking the sheathing off at the bottom because, again, OSB, the failure is going to concentrate there due to the nature of the material. For plywood, maybe it wouldn't have had to have come off potentially. It wouldn't have delaminated, could have dried potentially. So that's kind of from the forensic side, how we use code, ESRs, manufacturers, installations, and reference standards in code to understand resilience. I talked primarily about durability, but it could be anything. It could be severe storm resilience. It could be extreme temperature resilience. It could be any of those things. This is on the left, it's from science. There's basically over the past 40 years, there's like this global community of scientists, similar to the building scientists, but resilient scientists got together and said, hey, what are the common principles that you can use for anything? And those are the principles. So diversity, redundancy, I'll talk about. Connectivity, obviously, that everyone here probably understands. Connectivity of building enclosure to mechanicals, conditioned space to unconditioned space, very easily. So you think about how and if those are connected, and how your solar or your backup generation is connected. If it's whole building, or if you're just going to feed critical functions of the building with your generation, all these connections get to be really, really important in how you do it. This is the one we're doing now in Casanova. So to Kevin's point, where's my primary air control layer there? I've got the cantilever. There was steel coming across, spanning the garage, cantilevering both sides there. But I just note here, like Kevin talked about earlier, the air barrier and air sealing details, including location of the air barrier, have to be drawn on the construction drawings. And as a builder, I would tell you, other builders, don't be the person that draws that. Make the designer do their job and draw it for you. Work with them, because it's the same team. We're all there for the owner, and it should be constructive. And it's what we call an integrative construction process, similar to the integrative design process. We started to do that because on the integrative design process, we'd go to these charrettes, and the designer would be there, the owner would be there, the president of the air sealing company, or the president of the installation company, or executive of the installation company would be there. And then we would show up for the job kickoff meeting for the first unit in like a multifamily project like Kevin showed, 700 unit. Okay, we're at the first unit. Let's do everything we talked about from the design side. We worked really hard to get all of the air sealing details into the project documents, thermal control layer into the project documents. We go to that first unit to meet the insulators, and it's the first time they've ever seen it. They're like, nobody told me we had to do this. And it's call the supervisor. Hey, these guys want me to, air seal that rim joist over there. Nobody told us that. Well, it's not in the bid. Like, well, it's in the project drawing. So what we did instead was say it has to be an integrative construction process. We want to talk to the people actually doing the work before they show up that morning to do it. And we want to have them at the beginning of the process so they understand why it's so important too. Like, I forget the lady's name in Rome. So she understands why it's important before she shows up to do it, and that she's enabled to be successful every day on that job when she's doing it. So it doesn't become an adversarial process when we tell them you're going to fail your air tightness compartmentalization test, or your duct tightness test is going to fail. So I'm not by any means trying to say it's an adversarial thing with architects, but we should be working together with them to say you have unique design expertise, we have unique means, methods, constructability expertise. We know the limits of our subcontractors. We know their benefits. We know their talents. We know how to utilize them to their highest value. So let's work together. So let's detail all this at the beginning of it. So when the code officer shows up, it's already all done. So I don't have to tell Chuck here, hey, Chuck, so it wasn't on the drawings. I did this instead. Yeah, okay, great. And it was face-to-face, approved. Thanks. Here's your sample. You haven't gotten the other ones yet, no problem. Just go ahead and proceed. So I think I'll skip this. This is the site for the other project that I showed, just to say there's other really good tools out there. I'm actually starting to use AI to try to iterate a lot, and it certainly does lie to you. So it doesn't replace experience or knowledge, because it will shamelessly say, oh, no, I didn't actually do that. Like, I asked it to conform a permit set to a progress set, and I'm not sure with your projects, but for me, sometimes I can't even get to the Syracuse blueprint to get the latest set of job drawings in hand to get to the site before there's another change. So for me, I can take the permit set, progress set, drop it into AI, be like, hey, what's different? And so it gives you what looks like a really beautiful report. Okay, I've got to change my primary air controller resilience strategy. Then I'll say, hey, did you actually read the drawings? No, I only looked at the first 3 pages. Okay, so it got its limitations, but for stuff like humidity, for how to build on an east versus west side, to Kevin's point earlier, how to detail those lakeside facades, you can have it create energy modeling that replicates energy modeling. So for me to understand passive survivability, when I'm trying to understand my primary thermal control strategy, I can actually have it model, hey, if I go to an R60 versus an R49 at X dollars, does it make sense? No, it doesn't. So I can go to the client and say, you know, I know you read it or saw it or something, but it doesn't make any sense. And I validated it pretty quickly. If you want me to really validate it, I have to go hire an energy model and wait a couple weeks, because that's how long it's going to take me to get an answer back. And it's probably a few $1,000s. So it's been really, really helpful to try to figure and think through these things, even if it's only 60, 80% right. And it took a lot of time to train it.
Yes.
And the biggest problem I've got is continuity when it breaks session. So I have to have it store, write its own memory, basically, because it will learn. And when you correct its mistakes, it will get better each time, and it gets better very quickly, like 5 to 10 minutes quickly often. So it's very useful, but like the low level, the entry level, and mid level, I'd be really worried about, because Claude's a heck of a lot better than where I was starting out 30 years ago with this stuff. I'll put it that way. So this is kind of our conversation earlier about, energy code intended to provide flexibility, permit innovative approaches and techniques. We talked about how that relates back to ESRs. Manufacturers always trying to introduce innovation into the market. Builders typically having to suffer from the failures of the innovative products, like, the first low VOC paint. Kevin could probably talk about better. We were like the first ones to use that in the area, at least. We're also the first ones to install a James Hardy product before they had the clearances. And, like, I always have to argue with the Finnish carpenters, because Finnish carpenters want everything tight, everything, like, they don't want any clearance from a shingle to a sidewall. They want on it. And so, at that point, James Hardy didn't have any of the clearance requirements in it. We're like, it's a cement board. It seems like it's not going to work. We followed the directions. It failed, I think, on that lead house.
So it was the first certified house in the Northeast. We actually had James Hardy representative come out and did a full day training with us. Installed the complete system, and within a year. Out of that one house in 2004, birthed the 80-page color-coded book on how to install James Hardy's cider.
They paid us to do it twice, which we didn't want to do, because people hate doing things twice.
Yeah, but wants to pull siding off the house.
How'd that work?
So just to finish up, 3-4 minutes left. So that path is enclosure first. That's what the shearing layers tells us, is that structure's by far most important. And it can depend on building type. Not every house has to last 500 years. It could be a camp that's made from naturally renewable materials that you're intended to only be there for 10 or 15 years. Taken apart easily, and you compost it. So the durability is going to depend on what the purpose of the structure is, how long the client wants it to be there, and all that. But for us, for what we build, clients want to give it to their grandchildren. So we have to manage expectations in terms of how frequently we have to change roofing, what sort of maintenance you're going to need to do, kind of all of those things. But we focus enclosure first, particularly with the state looking at electrification. I think everybody's seeing, like, energy bills go up now, electric bills go up from the PSC changing the rate structure to it. If you look at it just from a pure energy density perspective, that calculation is from a consultant that's modeled the actual performance of thousands of heat pumps. And when he looked at his thousands of heat pumps, monitored data, said basically electrification is about 4.4%, 4 to 5 times more expensive from an operating cost perspective than natural gas, using what you see there are the assumptions for cost. And those cost assumptions will change. But he took that snapshot at that point in time, like a year and a half ago, and said, yeah, it's about 5 times more expensive to go all electric. So we have to condition clients to say, even if we do ground source, even if we electrify your domestic hot water, all of that, you're probably going to see a bigger electrical bill than you have now because you're using electricity to do more than you did at your other house. So even though you've got a passive enclosure, high performance, really efficient house, your electric bill is probably still going to go up because it's just more expensive and you're consuming more. So, Kevin talked rain screens, vapor control, those sort of things. I kind of talked about this before, thresholds. I'm always looking for what that key variable is, that key point of failure at any assembly, any material is, so then I can try to design in a way that, the wind never reaches the threshold that rips the roof off. The wetting of my wall never gets to a point where it can't dry. Kind of those things. And those are all quantifiable. You can put metrics to those. In fact, the manufacturers typically tell you what those metrics are. I just made this as kind of a last note. Everybody talks about passive survivability as an inherently good thing, and I agree that it is, especially in extreme cold. But when you get to extreme heat situations, urban heat islands that you would even see in Adirondack villages and Adirondack cities, your enclosure actually starts to punish you because it can trap heat if there's not any nighttime cooling, any sort of active system that would dehumidify and condition the space. So just to say, if everyone starts to shift to more passive building or enhanced thermal control, just be aware that there's a counterintuitive impact on extreme heat for prolonged events, and particularly power outages. I guess the last thing I would say here too, that's where diversity becomes a strength, and redundancy becomes a strength that has value. So if you're thinking about the function of how to provide a livable environment for your client, maybe not comfortable, but livable, shelter in place without heat, the first strategy is going to be passive survivability, enhanced enclosure. However, if you can add some sort of active backup like that, battery, whatever it is, then you've got 2 different ways you can provide that same function. So if the power goes out, you've still got passive survivability, but if the power goes out and you've only got passive survivability, you actually can enhance the resilience if you add battery storage, or you can island your PV. So the more ways that you can provide the basic functions to your clients that aren't wiped out from that same disturbance, the better it is. So I would just leave it there. Probably don't have time to go into this. Some of the stuff I'm using for Claude right now, like, hey, Claude, what does future climate and Skinny Atlas look like? Did you really read the data, Claude? Yeah, I did. Okay, so give me a table on whether I am making my recommendations based on what the future climate is going to look like. Because who else do you call for that? 30 years ago, like you said, it's the Wild West. We would call a Syracuse University professor and say, hey, you did a great study. Can you talk with us, just an hour on the phone or meet for lunch on what you think rainfall is going to look like in Skinny Atlas in 30 years? Well, yeah, I did the study and I think it's going to increase by 15% and, maybe, but now there's enough data to run a model and be like, okay, here's my site. You've got future climate models, you've got future temperature modeling that's already integrated into code. So what should my enclosure look like? So Claude will crank out, this took them 10 minutes last week to do. So I haven't validated this yet, but it's a starting point I wouldn't have had. And so what I'm trying to understand is if I recommend larger sized rain gardens, for example, or bioswales, do I look like a jerk 40 years from now when the client's like, I haven't seen a drop of water in that for, the last 20 years. Or, hey, you were right on that bioswale to the south. We got overwhelmed last week and so same thing with, you can do it with, we do something different, but you can do a structure, for example. You can put the code metrics in. You can put FIAS in, you can put the project design in. I probably should have gotten rid of the owner's name there. Code, all that, resilience already in the code, kind of the graph I showed you guys earlier in the reports the ICC's prepared, kind of where it misses. There's no maximum indoor temperature. New York City's actually passed, or is considering a local law that requires building owners to install air conditioning. They're requiring air conditioning be installed to maintain a maximum indoor temperature during heat waves. So how do you even monitor? How do you enforce it? How does the code officer show up? Hey, I saw your sensor. You violated the maximum indoor temperature last week, so here's your violation. No passive survivability requirement based on historic climate data. Compound events are when you get severe storms and power outage. Or typically when you have a heat wave, you also have a storm. Or you have a storm and a power outage. So you have to think from isolated events to all the stuff that hits at the same time. So I'll leave it at that. Just say thank you very much.